Hello everyone, in this tutorial we will learn about Apache Kafka. By the end of this tutorial, you will learn what is Apache Kafka and the terminology like message, topic, partition, broker, replica, cluster, and how do the message gets replicated within a cluster, what is replication factor, and also what is a producer, consumer, and consumer group. You learn some details about Zookeeper, and at the end of the tutorial we will do some practice on setting up Kafka and Zookeeper, and we'll create some topics and produce and consume messages from the topic. Let's go ahead and start with what is Apache Kafka. So what is this Apache Kafka? So Kafka is a distributed event stream platform, and it's created by LinkedIn. However, it's been open sourced and currently it's maintained by Compliant. Kafka is distributed and it has a resilient architecture, and it is fault tolerant event streaming platform, and it is horizontally scalable, and it can have hundreds of brokers, and it can handle millions of messages per second. It gives high performance with very low latency, which is almost real time. It's being used by 2000 plus firms, examples like Airbnb, LinkedIn, Netflix, Walmart, Uber, etc. And it is mainly used as transportation mechanism. It has other applications as well, which you will see in short. Every enterprise application creates a lot of data. It could be log messages, it could be metrics, user activities, outgoing messages, or something else. When these applications are producing huge amount of data, the enterprises has to do some analytics or perform some metric gathering or some kind of processing they have to do. So in order to process this data, the data has to be moved. How do we move this data? So moving of this data becomes nearly as important as the data itself. Suppose we have a source system and we want to send data to multiple target systems. So for this we need to know multiple details, like it could be how the data needs to be transported, what protocol should we use, and what is the contact between the systems. And as the target systems increases, the load on the source systems too increases, and it becomes quite complex. So in order to address such problem, we have the Kafka event stream platform. So the source systems can have multiple producers, and they can produce the messages at their own speed without waiting for a target or bothering about the pressure that the target has to handle. So targets get the data from the event streams at their own pace. So there are many use cases, like it could be messaging system, activity tracking, gathering metrics, application logs, stream processing, and decoupling system dependencies, big data integrations, etc. Now let's go ahead with the terminology. What is a message? A message in Kafka is a key value pair with some metadata. And what is a topic? A topic is a particular stream of data. We can think it of as a table, and the topic has a name. And what is a partition? The topics are split into partitions, and each partition has a number. The messages that comes are pushed into the partition, and all of these messages are ordered within a partition. So let's suppose we have a topic, and each topic has multiple partitions, and the messages that are being pushed store into the partitions, and the messages within the partitions are in order. So each message within partition gets an incremental ID called as offset. So whenever we push a message, it gets a number that's called offset number, and the data within the Kafka can be kept for, and by default it is 7 days. And the data that is pushed to Kafka is immutable, which means we cannot modify it. the data assigned to partition using hash of the key. So whenever we push a message, which means a message has a key value pair, so using the hash of the key, the partitioner decides to which partition the message should be pushed. So similar messages goes to the same partition if the key is same, or else it could be random or evenly distributed among the partitions if the key is not provided. And we have a replica is copy of each message, copy of each partition. We will see that in short. And what is a broker? A broker is nothing but a server, and each broker has an ID, and each broker stores certain partitions of a topic, which means an entire topic is not stored in one broker. It can be spread across multiple brokers. So if a client is connected to one broker, it can provide the metadata of the whole cluster. So each broker stores the information of rest of the brokers within a cluster. So even if the connected broker is down, the client still has information about the cluster. So cluster can have any number of brokers. So what is a cluster? Cluster is nothing but collection of brokers. Now let's see topic replication factor. Topics should have a replication factor greater than 1 to avoid issues. So what is this replication factor? So whenever we send a message to a topic, we want to create a replica of that message, so that just in case if a broker is down, we want the data available at all the time. So the second copy acts as a leader and sends the data to the client. Let's consider topic A with 3 partitions: partition 0, partition 1, partition 2, and these partitions are spread across a cluster. That is, partition 0 is stored in broker 1, partition 1 is stored in broker 2, and partition 2 is stored in broker 3. And we say that we want the replication factor of 2. That means each message should have an additional copy, and also which says each partition should have an additional copy. So at any time, only one broker can be the leader for a partition of a topic to receive and serve the data. So even we have 2 copies, two similar partitions, but only one partition will be the leader, which receives the data and also responds to provide the data to the client. The other partition is just as a backup. It's a copy of this partition. Just in case if broker 1 is down, this replica becomes the leader for this partition, and the data will be received into this partition, and also the data will be sent out of this partition to the client until this broker 1 comes up. Okay, who decides this leader and who decides this replica? This is taken care by Zookeeper, which you will see later.